Continuing with our series of video on power plant, today we are presenting a video on CMC mode. Here CMC stands for the coordinated master control. So before we go on deep in a video, I will give you some points which we are frequently using in the video. So the first term is the EHTC. This stands for the Electro Hydraulic Turbine Controller. So with the name, from its name you will get an idea of that it is a controller, a turbine controller, which is an electro-hydraulic type. There are two types of controller, the hydraulic and electro-hydraulic. The hydraulic, you can understand that it is both are the oil operated, but the hydraulic is manual. You can't control it electrically. But electro-hydraulic can be controlled electrically through the pulses, signals, electrical signals. Okay, moving next. The CMC stands for the co-ordinated master control. The first term defines the meaning of this CMC, that co-ordinated. That this will coordinate between the 2 points. The two systems will coordinate so to give a perfect control of the system, the unit that we are running. Okay. So in the CMC, the first term is the first input is the load set point. So this unit controller is the main block which controls the unit. Okay. We have an input here which is a load set point which is given manually to the CMC page, and the output of the unit controller is a feed forward signal. So with the name of the feed forward, you can get an idea that this is a this is an anticipatory signal. Anticipatory means that it gets that it's suppose that what will happen in the future. So if we are doing something and what will happen in future, it anticipates that, okay, and then it gives a signal. So that signal is a megawatt error signal. Now in the CMC, the coordinated, we talked about coordinated, okay, earlier in the video. So there is a coordination between these two controllers, these two. The Boilermaster and Turbine Master controller works in a coordination. That's why this term coordinated has been put here. The Boilermaster, as the name suggests, it controls the boiler, and the Turbine Master controller, it controls the turbine. Okay. So in the Boilermaster here, we have two inputs. The first one is a feed forward signal, and the second one is a MS pressure set point. The feed forward signal from the unit controller is fed in this Boilermaster, and the second input is the MS pressure set point. So as we give the load set point, there is also option of giving the MS pressure set point. Okay, the MS pressure set point is the main steam pressure set point. Here also one more input is there, that is the actual MS pressure. Actual MS pressure at which the unit is running. Now there are three inputs to the Boilermaster, and the output, there are two outputs. The one output this, and second output is this one. The first output is a fuel flow, and the second output is a air flow. So based on all the inputs, the Boilermaster is fed with some graph. That graph we can change. There are predefined values that is supplied by the OEM. Okay, and based on that input values, it decides the output. That is a fuel flow and air flow. So the fuel flow and air flow will be next fed to the fuel controllers, and the air flow set point will be fed to the air flow controller. Now, as we talked about that there is a coordination mode, so they will work in the equilibrium to maintain the unit. Okay, these two controllers. So the next one is a turbine master controller. Turbine master means this is a master controller of the turbine. Although there are the many mini controllers in the turbine systems, but this control all the loops and the overall. Okay. So in the turbine master controller, we have two inputs. The first one is a megawatt error. Okay. So this one megawatt error is not the feed forward signal we have got here. Okay. This is not that signal. This megawatt error is the difference of the load and actual load and the set point. Okay, and the second input is this one is derived from a function whose two inputs are actual pressure and a pressure set point. So these are the ms pressure. Okay, so the ms pressure set point and the actual ms pressure are fed to a function which generate a output based on the values which are fed to them, predetermined values, and that is a wholly fed to the turbine master controller. The output of the ESTC or the turbine master controller is the ESTC input. So this one is fed to the ESTC input, and in ESTC that will open the control valves, okay, of the HP turbines and the IP turbines, and that will increase the load. So we will discuss the ESTC in our next videos and upcoming videos. This is a whole overview of the CMC mode, because the two controllers are working in this synchronism, you can say. Okay, and both are driving the different things. That this one is driving this turbine, and this one is driving this boiler. So why CMC mode is preferred? So friends, we know that boiler has a slow response and the turbine has a fast response. Boiler is having a slow response because we will feed fuel and we will feed air, and then it will burn, and then it will result in a rising of the drum pressure and so the ms pressure. So it takes some time. The time varies from the different boiler, from this 110 to 800. The time varies, and it is in about the range of the 8 minutes to 10 minutes. Okay, so because of this boiler having a slow response in the unit which is not a CMC, so we get a lag of the 10 minutes or more than this 10 minutes or so, in which the boiler is responding, and there is a difference. We can't maintain the load because we are having such a difference in the stabilizing the boiler and getting the parameters. So in the CMC, what happens? There is a coordination. So there is a feed forward signal is fed to Boilermaster, as I told you earlier also. So before we are just getting load, we are also in this simultaneously we are feeding boiler also. We are anticipating that what will happen in future, that if we are increasing load, then the ms pressure will decrease at last, and to increase the ms pressure we have to feed fuel. So we anticipate that if we are increasing load, then ms pressure will decrease. So taking an anticipatory action, we will feed fuel also while we are raising load. Okay, so that is done by the CMC. That coordination, that simultaneous commands are given by the CMC. Okay, so now we will take one example, and I will try to explain you that how this all phenomena goes. So suppose we have a load set point. Load set point is 160 now. Now this we are getting a demand from the grid, just the load dispatch center. So they are demanding this load set point is a 160 megawatt. And suppose we are running the unit at the load, our unit load is currently at this time is 150 megawatt. So seeing that we have a difference of this 10 megawatt here. Okay, the difference, the load which we are running and the load which the grid is demanding. Okay, so 10 megawatt difference is there. So we have to feed that load to the grid. So we have to increase the load. Okay, so how it will happen, how the phenomena will go, that we will the unit controller will get a load set point of the 160. Okay, and so getting an input as a 160 megawatt, unit controller will generate some output. Okay, suppose it is a X output. Okay, so while it will give command to this turbine master also, turbine master will sense difference in the load, that is a 10 megawatt, and it will give command to the ESTC. Okay, based on the inputs of the ms pressure, this set point and actual pressure, it will give command to the ESTC, and also while it is giving command to ESTC, the unit controller is feeding this feed forward signal to the Boilermaster. Okay, simultaneously these are all happening. These all are happening. Okay, the feed forward signal is fed to this Boilermaster. MS per set point. Suppose we will kept MS per set point at a 145. It is fixed in a unit. Okay, and the actual pressure, as the currently actual pressure is 140. Okay, assume it is that the pressure is MS pressure is falling because the load is increasing. So okay, so considering these three inputs, this feed forward, this MS pressure, and the actual pressure, the Boilermaster will increase the fuel and increase the airflow because the demand is increasing. Okay, and also the turbine master, because the load difference is now plus 10 megawatt, so the ESTC input will also increase. So this will lead to the opening of the control valves also open, and we will reach at this desired load. Also, as the fuel flow and the air flow are increased, so the MS pressure will start rising. Okay, and therefore we will reach the actual this MS per set point also. Okay,